Hi, welcome back to this Fundamentals of Machine Learning tutorial. In this video, we'll be discussing reinforcement learning. Unlike other types of machine learning, reinforcement learning is all about making decisions sequentially. It is similar to teaching a dog new tricks. You reward the dog for a trick done correctly and provide no treat for a trick done incorrectly. Over time, the dog learns to perform tricks that maximize its traits. Let's look at key concepts of reinforcement learning. Here we have an agent, environment, actions, states, and rewards. The agent is the learner or decision maker in reinforcement learning. It interacts with the environment to achieve specific goals. For example, in a game, the agent could be the player making moves to win. We have the environment as well. The environment encompasses everything the agent interacts with. It could be a physical setting, like a robot navigating a room, or a virtual space, like a video game. The environment responds to the agent's actions and provides feedback. Then we have action state rewards. So I'll start with states. The state represents the current situation of the environment. It provides the context needed for the agent to make decisions. For example, in a chess game, the state will be the current arrangement of pieces on the board. Let's look at actions now. Actions are the choices available to the agent at any given state. The agent selects actions to influence the environment and moves towards its goals. For instance, in a self-driving car, actions could include accelerating, braking, or steering. Then we have rewards. The reward is a scalar feedback signal from the environment that evaluates the outcome of an action. So it tells the agent how good or bad its action was in achieving its goal. Positive rewards are given for desirable outcomes, while negative rewards or penalties are given for undesirable outcomes. So now, let's look at how reinforcement learning works. The goal of a reinforcement learning agent is to learn the best actions to take in different situations to maximize its total reward over time. And the process involves exploring the environment to find out which actions earn the highest reward, then developing a strategy or policy that tells the agent the best actions to take in each situation. So here, remember the agent and environments. The agent like the learner, like a robot or character in a game, and the environment as the world it interacts with. And there's an initial setup. The agent starts with no prior knowledge and follows a basic strategy to decide what actions to take. But it learns by doing. So the agent observes its current situation or state and chooses an action to perform, like moving left or right. After taking the action, the environment responds by giving the agent a reward, that's like a score, and changing the situation, that is its state. There's also a feedback loop. The agent keeps trying different actions, learning from the feedback, and gradually figures out the best action to take to get the highest rewards. But there has to be a balancing act. So the agent has to balance between trying new actions, that's like exploration, or sticking with known good actions, that's exploitation, which we'll learn soon. And he needs this to learn the best strategy. So rewards are crucial in reinforcement learning. They guide the agent by providing immediate feedback on its actions. Positive rewards encourage the agent to continue performing a particular action, while negative rewards or no rewards discourage it. Think of it like playing a video game where points are gained for collecting beneficial items and lost for hitting obstacles. Now let's look at policies in reinforcement learning. A policy in reinforcement learning is a strategy used by the agent, defining which action to take in a state. So it's like a guidebook that tells the agent what action to choose based on its current state. And it can be deterministic, so it always chooses the same action for a given state, or stochastic, and that means it chooses actions based on possibilities. So the same state might lead to different actions over time. And how do policies work? So when the agent is in a particular state, it looks at its policy to decide which action to take. For example, if the agent is playing a game and the state is low on health, the policy might suggest seek health packs with high probability. And they're also learning policies. So at the beginning, the policy might be random or simple. As the agent interacts with the environment and receives rewards, it updates the policy to favor actions that lead to higher rewards. Over time, the policy improves based on the agent's experiences and becomes more effective at achieving goals. And a purpose of this policy is that it helps the agent make the best possible decisions to maximize rewards over time. So that's for policies. So how do agents learn? Agents learn primarily through some methods. We have model-based learning, model-free learning. With model-based learning, it creates a model. That's the agent. The agent creates a model or plan of how the environment works. So this model helps it predict the results of different actions before actually taking them. And how it works is that it plans ahead. So the agent uses its model to simulate different actions and see what might happen. So this helps the agent decide the best actions to take without needing to try everything in real life. And it uses predictions. So by predicting the outcome, the agent can make smarter decisions and avoid bad actions. Example, imagine you have a map for a new city. Before you go, you use the map to plan the best routes to avoid traffic. So this way you can choose the best path without having to drive through every possible road first. Let's look at model-free learning. So here, the agent learns directly from its interactions with the environment without any prior knowledge or a model of how things work. So it works maybe by trial and error. So the agent tries different actions and sees what happens. It gets rewards or penalties based on its actions. We also have learning from feedback. The agent uses this feedback to improve its actions. For example, if taking a certain action often leads to rewards, the agent will prefer that action in the future. For example, imagine you're playing a game and trying different moves to see which ones score points. Over time, you learn which moves are best based on your experience. And under model free learning, we have value-based methods and policy-based method. With value-based method, the agent learns how good each action is by trying them out and seeing what happens. You'll see Q learning soon. Like in Q learning, the agent figures out the best actions by learning from what it gets. Then we have policy-based methods. So here the agent learns what actions to take directly by improving its strategy based on rewards. So it focuses on making its actions better over time, like fine-tuning a recipe. Let's look at balancing exploration and exploitation. With exploration, it basically means trying out new actions or strategy to discover their effects. So it's like experimenting with different possibilities. And it's important because by exploring, you might find new ways to get rewards or learn about better actions that you didn't know before. For example, if you're trying a new recipe, you might experiment with different ingredients or cooking methods to find the best flavor. So this helps you discover new possibilities. Then we have exploitation. So it means sticking with actions or strategies that you already know work well. It's about using what you've learned to maximize rewards. And it's important because by exploiting, you make the most of what you already know to get the best results based on past experience. For example, if you've already found a recipe that you really like, you might choose to make it again rather than trying a new one. So this ensures you get a good outcome based on your current knowledge. So the challenge for exploration and exploitation is that you need to balance exploration, that's trying new things, with exploitation, using what you know works to maximize your overall reward. So in practice, for example, In a game, you might try new strategies, that's exploration, to see if they improve your score. But you also keep using strategies that have worked well in the past, that's exploitation, to, ex- to ensure you continue to perform well. We have examples of reinforcement learning. So, for example, in developing autonomous vehicles, the agent as the car learns to make decisions like steering, speeding up, or braking based on the state of the environment. And other vehicles on the road or conditions to achieve a goal, reaching a destination safely and quickly. So this is one application of reinforcement learning, and there are various other applications that can be applied in health and finance as well. We have various reinforcement learning techniques. Here we'll discuss Q learning, deep Q networks, and policy gradient methods. With Q learning, it's a popular model-free algorithm where the agent learns the quality of actions of policy from their possible future rewards. So it's a value-based method where the agent learns the value of taking actions in different states to decide the best actions. And how it works is that the agent keeps a table or a model of Q values that estimates how good each action is in each state. So after taking an action and getting feedback, that's the reward, the agent updates this table to reflect what it has learned. The goal is to choose actions that maximize the long-term rewards based on these Q values. So imagine a robot learning to navigate a maze. It updates its tables of Q values every time it explores a new path and gets a reward or penalty. So then we also have deep Q networks. And this is an extension of Q learning that uses neural networks to handle complex environments with many states and actions. There will be a video on neural networks, but it was made to mimic the human brain. So how it works is that instead of using a simple table, the agent uses a neural network to estimate Q values for different actions in each state. So it helps the agent handle environments with a large number of possible states. So the robot uses a deep neural network to navigate a complex maze with many possible paths and obstacles, learning efficiently from its experience. So this is the deep Q network. So let's look at policy gradient methods. In policy gradient methods, the agent directly learns and improves its policy, so which determines the actions to take in each state. And how it works is that the agent adjusts its policy to make actions that lead to higher rewards more likely. So it uses the rewards to compute how to adjust its policy, focusing on improving the probability of good actions. So the robot learns to favor paths that lead to more rewards by adjusting its strategy directly rather than just using a value table. So, reinforcement learning continues to be a frontier in artificial intelligence, pushing the boundaries of automated decision making and adaptive systems. So, thank you for watching. In the next video, we'll look at evaluation and then you'll see the practical aspects of this type of machine learning. Thank you.